This is lesson 2.2 of Algebra 3. Learning targets for this lesson. So after watching this lesson as a student, you will be able to understand terms describing characteristics of parabolas, know and interpret parabolas expressed both in vertex form and in standard form, and be able to graph parabolas when given equations either in standard form or vertex form. Okay, so starting out, we're knowing this as vertex form. So the reason why we call this vertex form of a parabola is because the vertex of the parabola is apparent in the equation. So the vertex is located at the point h, k. Notice how you reverse the sign of the term inside. And remember what a vertex is on a parabola, that U-shaped graph. This right here is the vertex, the base of it. It could either face up like this one, up making a right side up U, or down, upside down U, where that dot is the vertex. And it's up when A is greater than 0, and it's down when A is less than 0. To find other points, you use this value of A. So for example, had A been, let's say it's 3 times x minus 2 squared plus 1. Let's say it's that. Y equals 3 times x minus 2 squared plus 1. Our center would be at 2, 1. Our vertex would be at 2, 1. And then it opens up because we have a point at 3. So up, because it's positive 3. And then from 2, 1, so 1, 2, 1 right here, to find the next 2 points, you would go right 1 up 3 and left 1 up 3. That's how you know how far to go up. You also have what's called an axis of symmetry. And it passes through the x-coordinate of the vertex. So what's called the axis of symmetry, it is x equals h. It's the x-coordinate of the vertex. And it's called the axis of symmetry because points across here are equidistant on either side. So let's do an example together and I'll show you what I mean. Okay, so first thing, we have our vertex. Vertex is located at the point 1, negative 1. Let's change our. So 1, negative 1. So we can put our point 1, negative 1. There's our vertex. And we know our axis of symmetry is x equals 1. We can put that on here. I'm going to put that on here as a vertical dashed line. Axis of symmetry right there. All right, and then we know this, based on the value of A here, we know A would be 1, because there's an implied 1 right there. So this opens up. So from here, we know we can go right 1 up 1 and left 1 up 1. And then we always want to create one more point. So you want 5 total points to graph. And we can say, okay, so since I already have my x and y axes, or x and y intercepts, I can't find another intercept, but what I could do is just plug in a value, like plug in 3 to gain one more point. So I plugged in 3 up here, So if we're making an XY chart, and I plug in 3 to get a fourth point, it would be 3 minus 1 squared minus 1. That's 2 squared, which is 4, minus 1 is 3. So we'd be at the point 3, comma 3. So here we are, next point. And we can use the axis of symmetry to jump equidistant on the other side. So we found this point, and then we use it to find its symmetric partner point, its reflected point across that axis of symmetry, to find that right there. And that would be the point -1, 3. You don't need to put that up here, but had you plugged in -1, it would confirm that that was also 3. And then we draw our line to make our curve. And there we go. Remember, we always want to use 5 points. 5 points. All right, let's do another. So we've got x plus 3 squared plus 1. So vertex at -3, 1. Axis of symmetry is just the x-coordinate of the vertex. That's x equals -3. When we plot those points, -3, 1. Axis of symmetry right there. Okay. And then we know our value of a is 1, which means it opens up because a was positive. And we know we're going to go up 1 from that point. So we go from here, our vertex, we go right 1, up 1, left 1, up 1. And we went up 1 because this had been 1 right here. Had this been a 2, we would have gone right 1 and left 1, up 2. Okay? So now we can use one more point. You can either use the intercepts if you ask for those, or we could just plug in one more point. So we can plug in -1, since -1 is the next x value over. I also could plug in -5. So I plug in -1, then I get -1 plus 3 squared plus 1. That's 2 squared plus 1. That would be 5. 4 plus 1. So we're at -1, 5. And then I can use this to get my mirror point, the point across here. So I'm 2 away, so I go 2 on the other side, and there's my other point. And now I can draw my curve. And those are my 5 points. Remember, always 5 points. Makes it more accurate. Okay, so generally speaking, when we graph, you find the vertex and also the axis of symmetry. You decide if it opens up or down, and then use that to graph points 1 unit left and right of vertex. Then you find one other point, sometimes x-intercept or y-intercept, sometimes it could just be another random point. Then you mirror that point and you draw the parabola. Always want 5 total points. 5 total points for accuracy. Okay, next, let's talk about, this is called standard form of a parabola. Standard form. So when we have standard form, we always want to start by identifying the vertex, but it must always be in this standard form version where the x squared term is written first, x term second, constant term last, where a, b, and c are the coefficients of each of those terms. So to find our vertex, we find -b over 2a. Remember, that's also our axis of symmetry. Axis of symmetry is still the x-coordinate of the vertex, so it's x equals -b over 2a. So our vertex is this, so negative b over 2a. Then you take that value and plug it back in for the x's to get the y value there. Up or down, same thing, you still look at that value for a. For the x-intercepts, you use your quadratic formula. And then for y-intercepts, you just look at this value for c. And we'll talk about the logic to that in a moment. All right, so working on an example. We start by identifying our vertex. It's a little harder with this because it's not in vertex form. But for our vertex, we're going to start by identifying a, b, and c. So a equals -1 here, b equals 4, and c equals -1. So to find my vertex, I know I'm going to do negative b over 2a and then f of negative b over 2a, which just simply is a fancy way of saying plug that negative b over 2a in for the x's in this function. So negative b over 2a is -4 over 2 times -1. So that's -4 over -2, which is 2. So we know the x-coordinate of our vertex is 2. Now to get the y-coordinate, I do f of 2. Well, f of 2 would be -2 squared plus 4 times 2 minus 1. Squeezing that in there. So minus 1. So I've got -4 plus 8 minus 1. That combines to be +3. So we got the vertex at 2, 3. A little more work that it took to do that. That's okay. Our axis of symmetry is still the x-coordinate of the vertex, so it's x equals 2. It's a line, remember. We'll call it a line. So we put that line on here. Make it a little... So there's our axis of symmetry right there. All right. Now we use, does it open up or down? Open up or down. And we know the value of a is -1, so we know it's down. So we know we're going to go right one and down one, and left one and down one. And why did we go down 1? Because that was the value of a. Okay, you go left and right 1, up or down, whatever that value of a is. All right, we need one more point. We could find the x-intercepts or y-intercepts here. Let's go ahead and find the y-intercept, because that's always easiest compared to x-intercepts. So if it asked for a y-intercept, or if we need an additional point, which is the next one over, what we do to find a y-intercept, we set x equal to 0 and solve for y in our equation. So set x equals 0 and solve for y. Remember, f of x is like y. So what we're going to do is we're going to plug in the zeros for all the x's. So y equals -0 squared plus 4 times 0 minus 1. And we have 0 plus 0 minus 1, that's -1. So that is our y-intercept. It's the point 0, -1 is our y-intercept. So we know that point there is the y-intercept. And then that's the 4th point. But remember, every time we have that 4th point, we really have the 5th point as well, because you can mirror it across the axis of symmetry to get our mirror point over here. I'm just going to call that MP for mirror point. And now that I have my points, I can go ahead and draw my line. Not the best parabola I've ever drawn, but that's the idea. And there we go. Let's talk about x-intercepts real quick too, while we're on the topic of intercepts. So to find the x-intercept, it's similar to the y, but instead of setting x equals 0 and solve for y, you set y equal to 0 and solve for x. So that would be 0 equals -x squared plus 4x minus 1. And then notice, because that doesn't factor, you're going to have to use the quadratic formula to solve that. So it'd be x equals, and you don't have to do this part. Once you have your 5 points, you're good to go. But there are occasions where I'm going to ask you to find the x-intercepts. So you're going to need to do this, which is why we learned that in lesson 2.1. So we would do negative b plus or minus the square root b squared minus 4 times negative 1 times negative 1 all over 2 times negative 1. So negative 4 plus or minus the square root of 16 minus 4 times a times c. That doesn't seem right. What did I do? B squared minus 4 times a times c. So I'm getting 16 minus 4. So we're at negative 4 plus or minus the square root of 12 all over negative 2, which simplifies into negative 4 plus or minus 2 root 3 all over negative 2. So 2 plus or minus negative 1 root 3, so I can just say 2 plus or minus root 3 would be your x-intercepts. All right, last problem. X squared minus 2x minus 3. So find our vertex. That would be negative b over 2a, f of negative b over 2a. So we have, remember, a is 1, b is negative 2, c is negative 3. So we have negative b over 2a would be 2 over 2, which is 1. Then we plug back in, and we get 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3 is negative 4. So 1 negative 4 is our vertex. 1 negative 4. And then axis of symmetry, that's x equals 1. We can go ahead and put that on our axis right here. Put that on our graph. And then we can find, using the little bit up or down, so then we know it opens up because a is positive 1, a equals 1. So we know we can go up 1 and up 1. We already have our y-intercept, so we can find an x-intercept as well as our next point. So to find the x-intercept, we set y equal to 0 and solve for x. So we say 0 equals x squared minus 2x minus 3. And we can use the quadratic formula here. So x equals negative b, that would be 2 plus or minus the square root of b squared, that's negative 2 squared, minus 4ac, 4 times 1 times negative 3, all over 2a, that's 2 times 1. So bringing it up here, 2 plus or minus the square root of 4 plus 12, all over 2. 2 plus or minus the square root of 16 over 2. That's 2 plus or minus 4 over 2. Root 16 is 4. So I say 2 plus 4 over 2 and 2 minus 4 over 2. So that would be 6 over 2, which is 3, and negative 2 over 2, which is negative 1. So 3 and negative 1 are my two x-intercepts. Then I can draw my graph, and I am good to go. Remember, always 5 points. That concludes our lesson on lesson 2.2.
Quadratic parabola word problem. So here we're going to use, so what this models here, if you look at the graph, is it models the flight path of a shot put. So we're going to use this red graph because it says we're going to use g of x. So there's our function, negative 0.04x squared plus 2.1x plus 6.1 equals g of x. And notice how g of x, this y, represents the shot put's height, whereas the x represents the shot put's horizontal distance. So both of them are distance. This is just horizontally, and this is the height above the ground. So notice how the maximum height is represented by this the vertex of the parabola. So what is the max, if we want to answer the question, what is the maximum height of the shot put, and how far from its point of release does this occur? So what that's asking is essentially about the vertex, because asking what's the y coordinate of the vertex, that would be what's the max height, and how far horizontally from the original point, how far horizontally from the original point were we, that would be the x coordinate here. So we can find that x coordinate and y coordinate by simply finding the vertex of this parabola. So the vertex of this parabola, remember, when the parabola is in standard form like this, our vertex is located at negative b over 2a, and then f of negative b over 2a, which is a fancy way of describing, we take what it was for our x value and plug it in for the x's to get the y value. So let's do negative b over 2a. We're going to do negative 2.1 divided by 2a. That would be 2 times negative 0.04. So we got negative 2.1 over negative 0.08. And we calculate that. And we get 26.25. 26.25. So that right there is the x coordinate of our vertex. So 26.25, comma something. So that's the x coordinate of the vertex. Notice how far from its point of release is it? That's 26.25 feet. 26.25 feet. And then to find the y coordinate, we just simply take this x value and plug it into our original. So we're going to do negative 0.04 times 26.25 squared plus 2.1 times 26.25 and then plus 6.1. This will answer the question, what's the maximum height of the shot? Because that's the y coordinate of the vertex right here, what that y value is. Based on the look of the graph, it should be something in the low 30s. So let's see if we can get this. So we plug it into our calculator. Squared plus plus 2.1 times 26.25 and then plus 6.1. So we get 33.625, which is right in the whereabouts of what we were supposed to get. 33.6. So maximum height of the shot is 33.625 feet. All right, what is the shot's maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw? So that's asking how far did it go here. So it should be around 55. The way we find that is by finding the x-intercept. Find the x-intercept. So to find the x-intercepts, we use the quadratic formula. X is equal to negative b, so that would be negative 2.1 plus or minus the square root of b squared, that would be 2.1 squared, minus 4 times a, 4 times negative 0.04 times c, which is 6.1. So we're going to put this in our calculator. All over 2a. 2a is negative 0.08. So we can put this in the calculator. Okay, so we've got 2.1 squared. So we've got the square root. We just want to calculate this. The square root of 2.1 squared minus 4 times negative 0.04, so it's going to be plus 4 times 0.04 times 6.1. Plus 4 times 0.04 times 6.1. Alright, so we get our value for that. 2.32. So this part of it's 2.32. So we got negative 2.1 plus or minus 2.32 all over negative 0.08. And then we just calculate those two. So we've got 2.1, negative 2.1. We want the positive version. So minus 2.32. Negative 2.1 minus 2.32 all over negative 0.08. There we go. And we get 55.25 right here, which is exactly what we should have gotten based on the look of the graph. 55.25. So 55.25. And then lastly, to answer this question, from what height was the shot released? Well, to find the release height, that's just the y value when it's at the very beginning, when x is 0, when it hasn't moved at all horizontally. Well, if we plug in 0 for all the x's, we'll get y is 6.1. So that's how we get 6.1 feet for this problem down here.